Okay, I just thought of one simple optimization that we can do. And remember when we set up the database context, we just hard-coded the connection string into the database context implementation. Well, now that we have our application layer ready that actually utilizes a configuration file, we can move that part of the configuration actually into this web config file. And for that, we're going to go into our infrastructure project and open up the database context class. And here, remove this connection string. Well, first, we're not going to remove it, we're just going to simply copy it. There we go. And we're going to go into the web.config file in the application. And there should be a section called connection strings. If not, we're going to create one. There's not. So we create one here, up here. And there it is. And we're going to add a connection string and name it, I don't know, speedrun database. And paste the connection string here. Yeah, we should be good. That's it. And now, since our application is the executing assembly, when we read from a configuration file in this separate assembly here, you would actually read from this web config, since the web config is part of the executing assembly. So instead of just hard coding the connection string here, we're going to read it from a config. And there should be a class configuration manager if I remember correctly. Yes, there is, but we need to add a reference to system configuration.dll, which is a different assembly that we haven't included yet. And we can either do that using IntelliSense right here, or we could go here and add. Let's add it as a NuGet package. Manage NuGet packages, system configuration. There it is. Is it compatible with our? Yes. Yes, that is fine. We're going to. What was that? Okay, that's fine. So now that it's installed, we just need to reference it with a using directive. I mean, we need to reference the data, the namespace that it's in. And now we can use the class, and we can use the configuration manager class and access its static connection strings property. And I think it has an index operator. Yes, it does. And here we can pass the name of the connection string, and we named it speedrun database. I'm going to copy that. There we go. And that is going to return an instance of connection string, and we need to actually convert that into a string by simply calling the toString method. So yeah, that's it. So now, if we were to move the database to somewhere else or just use a different database, we don't have to actually go into the code here and change a hard-coded string literal. Instead, we go into the configuration file, which was actually designed for this purpose, and simply change the connection string here. And this should still be working. Let's see. Oh, come on, why is it? So let's invoke the service operation again, and if it still returns all of the speedruns properly, then everything is alright. Oh, there's an error. Oh, right, I know what it is. We also need to add a reference to the configuration assembly in our web application, because it's the executing assembly, and essentially this is going to be the one that's going to read the config. So yeah, add a reference here. Whoops. There we go, install. Okay, for some reason my Visual Studio just crashed. It decided to just shut down. I don't know. But here we are. So now let's invoke the service operation again. Okay. His error is false, and we still get all of the speedrun entities or speedrun objects from the database. Everything's fine. Alright, so now we're back in Visual Studio. Actually, for you it was probably just a couple of seconds or minutes, but for me over an entire day has passed. But I'm back at it, and yeah, what we're going to do now is create a small client application. It's going to be a very simple console application that consumes our speedrun web service, invokes the one and only service operation that we created, and then it will simply display the results, the speedrun data on the console. Yeah, and for that we're going to, let's see. First of all, we're going to need to host this web service, of course. So we need to have it running and listening for requests. What we could do is actually install and properly set up IIS, which stands for Internet Information Services. It would actually be pretty simple. We could do that, but I think that would be a topic for another video. So if you're interested, then in a future video I can show you how to set up IIS on your machine so that you can locally host a web service like this. But for now we're just going to use Visual Studio's built-in IIS Express, which is automatically started when you run a web application like this. As you can see here, it also says IIS Express when you debug the application. Let's just start it up again. And when I start the debug mode here, Visual Studio will actually start IIS Express, and you can see that here as a tray icon. IIS Express, when I right click it, it will show all the web applications that are currently running, which is, well, of course, our Speedrun WCF web service is the only one here in the list. And the thing about IIS Express is it's basically merely for development and debugging purposes. As soon as I close this, as soon as I stop debugging, IIS Express will close, which in our case would be a problem because we want to actually use this service while we're working on our client application. One way would be simply to leave the debug mode running and then go into a separate second instance of Visual Studio. So just open up Visual Studio again, start a new solution there. That's one thing we could do. That would keep IIS running and keep the service up and running and hosted and listening for requests. Another way would be to set this up as the starting application, of course, and then instead of entering debug mode, we're going to click debug and say start without debugging, which will start up the service and keep it running as long as we keep Visual Studio running. You will see down here in the tray icons that IIS Express is running, even though the debug mode is not running. We could also do that. I think to demonstrate that basically our client application is completely separate from this application code here and from this solution entirely, we're going to actually go with the approach to open up a separate instance of Visual Studio and create an entirely new solution in that, in which we then create the client application, and it will have an endpoint listening to our web service application that is running in the other Visual Studio instance. I think that's what we're going to do. Like I said, you might as well actually publish this service and have it running on IIS on your local machine. Yeah, we're just going to keep it simple and do it like that. Also, this gives us the advantage that we can actually debug the service while it is running. So when it receives requests, we could put a breakpoint in the service operation and see what's happening there. So it does come with benefits and advantages. Okay, so I opened up a separate instance of Visual Studio, and I just realized that I forgot to apply a zoom to the entire screen. It was at 100%, now it's at 125% as it was before. Sorry about that, but there's nothing that you could have missed. So basically, yeah, shouldn't have been a problem, I hope. So okay, now that the separate instances opened up here, let's go ahead and create a new project. Click create a new project, and we're going to actually create a console application. We could use .NET Core because that would do actually, but let's go ahead and create a plain old .NET Framework console application here. Double click it. Let's say, I don't know, speedrun WCF .client, something like that. Yeah, 4.6.2 is not the latest, but it will do. I mean, we could choose a newer version, 4.8 maybe. It doesn't really matter. We're not going to use any features exclusive to 4.8 or something. So yeah, let's just go ahead. We could upgrade it at any point in time, so it doesn't really matter anyway. Okay, so yeah, we're here with our new console application, and let's go ahead, and when we start it up, we will see that it actually closes immediately. That's because it doesn't have any code in it, so it doesn't have any work to do. So it starts up and it's done with its work and closes back down. So if we want to keep it open, we could do something like console dot let's say read key, and before that we're going to output a message, press any key to exit, and start it up again, and it just says press any key to exit, and then I press, I don't know, J, it will close down, something like that. I think we're gonna keep this in here just to not have it shut down every time we start it. Okay, let's go ahead, and the first thing that we're going to do is actually create, have Visual Studio automatically create client code for us using the endpoint of the WCF service that is running in the other instance. In fact, I just shut it down in the other instance, so we're going to have to boot it up again. So I'm going into the other Visual Studio instance that is running in the background. I go here and I'm going to actually enter debug mode. It's going to open up Chrome, but I don't really care about that, so I'm going to minimize it, and I'm going to switch back into the other Visual Studio instance. And now that the service is running, we can have Visual Studio create the client code. So let's go ahead, and we should be able to do something like, hold on, I haven't done this in a while. Add service reference, right? You go here to references, right click it and say add service reference, and then you have to enter the address of the service, which is quite simple. We're just going to copy the address here. Well, basically it's just localhost, and the port is the one specified here. So yeah, I'm going to, copy this URL, put it here, and say, now we need the actual path, the actual complete URL of the service, which currently is simply, if I go in the other instance here and click View Solution Explorer, I can see here it's called speedrun webservice.svc, and that's, yeah, that's the suffix of the URL that I have to enter. Whoops. There we go. Speedrun webservice.svc. Go. And there it is. That's exactly the service I was looking for, and it's going to create the client code in the namespace that we specify down here. Let's say, well, speedrun web service. Let's click on advanced real quick. I have to, like I said, I haven't done this in quite a while. Yeah, generated classes will have the access modifier public. That's fine. We don't need to reuse any assembly references, so that's fine. Collection type will be array, which basically means in our data contracts, when there are collections, like lists, arrays, array lists, whatever you can think of, basically any implementation of iList or IEnumerable, something like that. Any collection type, when the client code is created, they're basically translated, or the generated classes will declare them as a simple array. We could choose list instead, linked list, array list, like I said, but an array will be fine. We don't care about that. Okay, speedrun web service. Okay, that should be it. So I click OK, and it's going to take a while, I think. Is it done already? That was quick. I mean, there's not much code to generate, but... Oh, sorry. Did I just... Hold on. Oh, there it is. Yeah, sorry, I was in the wrong Visual Studio instance. Yeah. Still, this is still impromptu. I haven't done any further preparation, even though some time has passed, and of course I thought about what I wanted to do next, but I haven't scripted out anything or something like that. Okay, so yeah, we're back in our client application here, and the service has been connected. There is client code that was generated. It doesn't show up here by default, but we can have it we can have it displayed. I think if I click here, I'll just double click it. Yeah, if we double click it, we can we go into the object browser, and here we can see, when I open this up here, we can see that it actually created a game class, a player class, and a speedrun class based on the data contract defined in the web service. Yeah, and here's the request and the response class, and of course a class that a client class for our web service. So that basically encapsulates all the methods that we need to use in order to communicate with our running service. All right, so let's go ahead. And I haven't even actually thought about any design for our sorry, excuse me, any design for our application, but I don't think we have to put too much thought into it. It's just a simple console application, so it's not going to consist of any application layers or something. It's just going to be straightforward and simple. Okay, so let's say we're going to create a new class and call it something like let's see, speedrun service reader or accessor. That's better. Speedrun service accessor, something like that. Okay, so now we have a new class here. We don't need to make it public because we're not going to reference it in any other assembly than our own assembly. Implicitly it will be internal, and we can also explicitly say it's internal. It doesn't make a difference. Okay, let's go ahead. What do we need? First of all, I'm going to create a region here, methods, and put a new method in that. And really all we want to do is read the speedruns from the service and display them. That's basically it. Okay. So what I have in mind for this speedrun service accessor class is that it will act as basically as a wrapper around the automatically created client code. And it will simply, what it will do is it will be responsible for communicating with the service and retrieving the objects from it. And it will also take care of all exceptions, errors that occur, yeah, and will react to them appropriately. So in order for us to do that, well, actually, yeah, I have an idea. Let's just start very simple. create a method here that doesn't return anything. We will change that later on. For now, it's just going to be void, and it's named get speedrun data. So far, it doesn't need to take any arguments. I don't think later on or in a future video, we're going to, like I said, have like different queries where we only want to retrieve speedruns from that and that, from this and that game, and I don't know, only speedruns by player X, something like that. But sorry, for now, this will do. So what we're going to do for that is create an instance of the automatically created client class. And as we specified previously, it's in a different namespace. Hold on. There it is. When we created the service reference, we specified the namespace to be speedrun web service. So I include this this namespace, and now I can create a speedrun web service client. But there's a couple of things to be aware of when we're working with those automatically created client classes, and that's the, well, for example, the error handling and the proper disposal of the client, of the instance. Thing is, in my opinion, Microsoft kind of screwed up the design here a little bit, because the those automatically created classes here, they do implement the iDisposable interface and therefore the disposable pattern. So one would think that properly disposing the client would be very simple by simply using a using block. Whoops. And then have the dispose method take care of getting rid of this instance properly. But that's not entirely true. The design is kind of flawed in that sense. The thing is, this works to some extent, but in cases where like the client gets into a faulted state because of some like a timeout or something like that, or because the web service was not available, something like that, it gets into a faulted state. And what the in the implementation of the dispose method of this client, what it actually does is it calls the close method. But the thing is, if it is in a faulted state because of a timeout or something, and you call the close method, it'll throw an exception. So it doesn't work. Instead, you would have to call the abort method, which will cancel the operation without gracefully closing the client, because you can't close it if it's in a faulted state. So yeah, way to go, Microsoft. But well, maybe it was intended, I don't know. Okay, so how do we solve this problem? Well, Microsoft actually has a certain recommendation for that, and we're basically going to do that, but not entirely. Let's just go ahead. We're going to use a try block here and a catch block. And what Microsoft would suggest is that, first of all, Microsoft would suggest to handle all the client logic here, and then after that, whoops, logic, and then after that in the try block, whoops, client. Close it. So as I said, close may throw an exception, and then here have it catch, I think it's called communication exception, if I'm not mistaken. Yeah. Then have it catch exceptions of type communication exception, and also in another catch, let's just go ahead and do that. And in another catch block, have it handle all exceptions of type timeout exception. And then have another catch block that handles all general exceptions. But we're not going to do it this way. We don't need to distinguish between these different exception types, because we're going to handle them the same way anyway. So we're just going to go with the good old Pokemon exception handling. Gotta catch them all. Okay, which is generally not good practice. So you should actually be more specific about the exceptions you want to handle. So this is generally, generally speaking, it's not a good way to handle exceptions. It's kind of a code smell, but in very simple scenarios like this, it's perfectly fine to use. So, and we're going to do that. So, let's go ahead. Sorry, I had to make a quick cut because my neighbors are arguing upstairs or something. They're just really noisy in general today. I don't know. Yeah, let's go ahead. And in case an exception is thrown, we're going to call the abort method. And that's fine. Yep. Okay. So now, here in our try block, we can actually call the method getSpeedruns, which is named after the service operation that we defined in our service contract when we implemented the service. If we take a look here, here in our iSpeedruns web service interface, which is marked as a service contract, we defined this method here, getSpeedruns, and marked it as a operation contract using the attribute. And yeah, this is what the method is named after in the client. So we can call this, and it will by default create two methods, one that is synchronous and one that is asynchronous. We don't care about the asynchronous one. We're simply going to call this method here. Oh, and actually it takes an argument of type speedrun service request. So we will have to create that request, even though it does not have any properties or whatsoever in it. Speedrun request, service request. And pass it to this method. And of course it returns a speedrun service response. And remember, we actually have some properties in there in the speedrun service response to determine whether or not an error occurred. So now we can check for that. So if an error occurred, we're going to handle that error. If not, of course, we're going to do something. And what is it that we want to do? We actually let's go up here and declare a new local variable. speedrun, an array of speedruns, and it's going to be null for now. And down here, as the last statement here, we will return those. Oh, right, it's void. Sorry about that. Yeah. Let's see. Yeah, okay. Instead, we're going to need that local variable, but let's see. Here we're going to assign the returned speedruns to our local variable. There we go. And if an error occurred, we can't do that. Okay, let's do something here. Let's create a new class. And call it speedrun fetch result. Actually, it doesn't need, whoops, it doesn't need to be public, but whatever. Okay, so let's think about how we want to model this class. Actually, what we want, this class should describe the result of a retrieval operation from the service, and it's going to look very similar to our response class with a few differences. First of all, of course, it will need a property for storing the instances that were retrieved. And we're going to go ahead and create a property of type IEnumerable speedrun. And that's in a different namespace, so I have to add a using directive. And this will be our speedruns. And actually, this is going to be a read-only auto property, because it doesn't make sense to change or to be able to set this property once it is set. We're going to add a constructor, and this constructor is going to take an sorry, an enumerable of speedruns, and it's going to have a Boolean argument is error. Oh, hold on, maybe we'll do it differently. Okay, actually, let's do it differently here. What we're going to do is declare a new enum type, and it's going to be called result type, and it's going to have the values success, server error, and internal error. And we'll have a read-only property here of that new enumeration type. Like I said, it's going to be read-only. Sorry, I had to make another cut there. Noisy neighbors. But okay. So now we have our result type as a property here in the speedruns. We need another property actually. In case there's an error, it's going to be named error message. It doesn't need a setter. It's going to be a read-only auto property. And let's make the first parameter be of type result type. The second will actually be the speedruns, and the third one will be an error message. Yep. Let's go ahead and initialize our properties accordingly. Result type speedruns and error message. Actually, in case someone passes null to the speedruns, we'll just assume that means that there are no speedruns. So instead we will assign an empty array here. And what this operator does, it simply, if the left operand is null, it will simply return the right operand of the same type, or of a derived type. Okay, same thing goes for the error message. If null is passed here, we'll simply assign an empty string. The result type, of course, can't be null because it's a value type. And actually now let's move this result type enum into its separate file by just right-clicking it here. Right-click, quick actions, move type to result type.cs. So yeah, now it looks a little more clean and tidy. Yeah, that's it. Let's not overcomplicate it. Let's override the toString method. Actually, there's one more property that I want to create here. Let's call it. Let's make it of type integer and call it result count, and it will simply return the number of speedruns retrieved in case any speedruns were retrieved. By simply calling the extension method count on this enumerable. And this is just an expression-bodied member here. We might as well syntactically write it like this, or we could also write it like this. But if it only has a getter, we can simply use an expression body for the entire property. Okay. And now the string method, the toString method. Actually here, let's use a block body. And it's going to return the result type as a string. It's going to it's going to include the number of results. Whoops. And in case the error message is not null or empty or white space, we also make it include the error message and return that. Oh, actually, there we go. So if there is no error message, the returned string will not even include it. Yeah, that's fine. Okay, that's it for our fetch result. Let's go ahead, go back into this service accessor here, and actually we're going to declare a new local variable here of type result type, which we just created, and we're going to initialize it with the value success. We're just going to assume everything is going to be alright. So now in this if statement here, if the isError property of the response is true, then something happened on the server side. That means something happened. The server actually successfully retrieved the request, but in the application logic of our WCF web service application, something went wrong. So it's a server error, and therefore we're going to whoops. Oh, it's actually called result, yeah. We're actually going to set our result variable to server error. And in case an exception is thrown, that means something has already gone wrong while communicating with the server. So while establishing a connection, maybe the server was unavailable, maybe a timeout occurred, something like that. So it's not an error that occurred on the server side. So we're going to set the result type to internal error. And then we can also go ahead and let's create a new local variable here called error message or error message. Let's just call it RSMG, something like that. And we're going to initialize it with an empty string. And then here, if an exception is called, we're going to set it to the exception message. And if an error occurred on the server side, we're going to assign the error message in the response to our error message variable, like this. And I think we're fine. Now what we want to return here is a new instance of speedrun fetch result, and now we will pass it the result, speedruns, and the MSG. Let's see. Okay, first of all, declare an array of speedruns, declare a result type, and declare an error message. We don't need this. Actually, let's leave it in. Create a request, pass it to the getSpeedruns service operation, and if an error occurred on the server side, set the result to server error, set the error message to the message from that response. Otherwise, assign the speedruns variable, then close the client. And if an exception occurs, well, hold on. No, that's fine. That's fine. I think we're good. Yeah. So far we don't actually need any type of constructor here. We may add one later on as this class becomes more complex, but for now all it really does is create a client and call one of its methods. Yeah, so that's fine.